Today we have 2 radical equations using your calculator. So before we solved radical equations algebraically, now we're going to look at it graphically through using our calculator. So the goal for today is to be able to solve a radical function and determine the solution is extraneous by using your graphing calculator. So given the equation, 2 is equal to the square root of x plus 6. Now we know how we solve this algebraically. We would square both sides and then solve and check for solutions. Now we want to look, given a graph of this, how do we know what our solution is, or if there is a solution? So we want to take this and we want to plug it into our graphing calculator. Well, right now we have 2 things set equal to each other, and both things that are set equal to each other are technically separate equations that we want to know where they're at. So we have 2 and we have square root of x plus 6. We can take those and plug both into our graphing calculator. So take a second and take out your graphing calculator. Go into y equals, and we're going to type in our 2 equations. So the left side is going to go into y1, and the right side is going to go into y2. So you should have something like this. y1 is equal to 2, and y2 is equal to the square root of x plus 6. They're equal to each other. They're 2 separate equations. Then hit graph. When you hit graph, you should come across something like this. The first one is our line, and the second one, we have that radical equation, which we have graphed by hand before. So what features within this graph might suggest what we can use to solve this equation? So hopefully you're thinking, where they cross, where these 2 graphs cross. And that's exactly what we're looking for. We're looking for where do these 2 graphs cross, and where they cross, that is going to be our solution. We may be able to eyeball approximately where this graph intersects, but our calculator will actually find the exact point for us. So we're going to go through the steps on how to do that. So now that we've looked at the graph, we want to figure out exactly where they cross to find our solution. In order to do that, you want to hit second and then hit trace, because we want that calculate button that's right above it in blue. So second, trace, and when you click that, it's going to bring up a screen that looks like this. Calculate, we've got value, 0, minimum, maximum. We want intersect. So we want to click on intersect here. Number 5, you can either just type in 5 on your calculator, or you can toggle down to 5 and hit enter. Once you hit enter, it's going to bring you to a screen, and it's going to have a flashing cursor. At the bottom of the screen, it's going to say first curve, second curve, guess, and on all 3 of those, since we only have 2 curves and we're only going to have 1 intersection point at most, first curve, hit enter, second curve, hit enter, guess, hit enter, and it's going to give you the exact intersection point. So once we hit that number 5 intersection, hit enter 3 times, and it's going to bring up your exact intersection point. So right now, it should tell you, after you hit enter 3 times, intersection -2, 2. So our exact intersection point is where our cursor is at -2, 2. Now, if you can remember back to when we were solving, we were always finding, okay, what does x need to be? So we're looking for our x value. So our x value is -2, So that is our answer. Our answer is x equals -2. And if we can see it on the graph, we can see they cross right here. It's not an extraneous solution. It is, in fact, the solution to this equation because they do, in fact, cross. If they cross, we have a solution. All right, let's look at another example. So this example says, solve the equation using your graphing calculator. We have the square root of 3x minus 2 minus square root of 9 minus x equals 0. So unlike the last one where we had an equation equal to an equation, right now we have two square roots on the left side. In order to plug this into our graphing calculator, we need to get two things equal to each other. So we need our square root equal to our square root. So I can just take this square root here and add it over to the other side. So I can add square root of 9 minus x. This is going to cancel, and I add it to the other side. I'm given square root of 3x minus 2 is equal to the square root of 9 minus x. So 3x minus 2 is going to go into y1 now, and square root of 9 minus x is going to go into y2. And then we want to figure out where exactly do they cross, going through the same steps we did previously. So take a moment, go ahead and plug this into your graphing calculator and find that exact intersection point, and then hit play to find the answer. So you should have put into y1 square root of 3x minus 2 and into y2 square root of 9 minus x. Hit graph, and you should have seen something that we have over here on the right hand side, but we wanted to find that exact intersection point. So remember, to find the exact intersection point, we hit second, trace. That's going to bring us to our calculate screen. Then we're going to hit number 5 for intersection. From there, it's going to say first curve, second curve, and guess. And on all three of those, you're just going to hit enter. After you've hit enter 3 times, it should tell you what your exact intersection point is. And that is 2.75, 2.5. So that means our answer is what x equals. That makes it true. And we have x is equal to 2.75. So the answer to this equation here would be x equals 2.75. That's where our graphs cross, intersect. That's our solution, 2.75. And example 3. Looking at this equation, what do you notice? We have the square root of x plus 2 equals -3. Well, hopefully you notice our square roots equal to a negative. And we know we can't have a square root equal to a negative number because we can't take the square root of a negative, so we're never going to get a negative output. So we know that this is going to be no solution. We discussed that algebraically, but what about graphically? So if we were to take this and we were to plug it into the graphing calculator, we would take square root of x plus 2 as y1 and -3 as y2. So go ahead, take a moment, pause the video, plug this into your graphing calculator, and look at that graph. All right, so your graph should look something like this. Well, we said this should be no solution, and looking at our graph, it also shows us there is no solution, because remember, a solution is when our two graphs intersect. These graphs are never going to intersect because we have one graph down here and we have one graph up here. This one's going to continue a horizontal line infinitely, and this one's going to continue to increase infinitely. Therefore, they're never going to cross. Therefore, we have no solutions. And anything that, when you solved algebraically, would be an extraneous solution. So we can look at a graph or see algebraically why we have no solutions. And this is not the only case we're going to have no solutions. There could be ones that are a lot less obvious. For example, the square root of x equal to the square root of 2x plus 1. This actually has no solution as well, but it's not quite as obvious because we don't have -3. But as we start to get more familiar with this, we're going to see some other types of graphs. Think about things like if one is our normal graph and then we have one that's stretched, it's always going to be up higher, so it's never going to cross. We could also have one as our parent function, and then the other one would be reflected. If it was reflected, they would never cross. So we've seen algebraically that there's a lot of different types that are going to have no solution, or extraneous solutions as we called them before. But also we can take a look at that graphically and see that sometimes we will have solutions when they intersect, and then sometimes if they never intersect, we have no solution. So the big takeaway, when we're looking at a graph of radical equations, how do we know that there is a solution? Well, it's where our graphs cross. Where there is an intersection point, there is a solution. If our graphs never cross, that means we have no solution.